This is a video on magnetic forces. The question reads, a two-turn loop of wire of radius r is fed a large conventional current I from long straight wires. A charge of magnitude plus q is a distance 3r to the right of the center of the loop. An electron traveling upward with speed v passes through the center of the loop, and the net force on this electron at this instant is 0. The Earth's magnetic field is negligible in this region. What are the magnitude and the direction of the current I? So here's the picture of what the loop looks like. As you can see, it has two turns, and the radius is r. The distance between the electron and the positive q charge is 3r. The electron is moving up, and this is the current I going in. So we know by basic principle that the magnetic force plus the electric force has to equal 0. And it did say up here that the net force on the electron at this instant is 0. So we know that that holds true. This is a picture of the electron with, we know that the electric field has to be moving in the negative x direction because of this positive q charge here. And as well, there's going to be an electric force to the right because of that positive q charge. And because of this principle, the magnetic force is going to have to be an equal and opposite magnitude and direction. So this magnetic force has to be moving in the negative x direction since the electric force is in the positive x direction. And using what we know in the right-hand rule, we can figure out the direction of the magnetic field. So we know the velocity is moving in the positive y direction. It's moving up. And since it's an electron and the magnetic force is in the negative x direction, we know v cross b is going to have to be in the positive x direction. So we know these three things at this point. So by doing the right-hand rule, v cross b and v, we get that b is going to be pointing outwards in the positive z direction. And so by using a different right-hand rule for the loop, we get that I is moving in a counterclockwise direction. So now knowing this, we can use this principle that the magnetic force has to equal the electric force. And we know these basic equations. Set those equal to each other and solve for b. Let me get this equation. So then we also know that the magnetic loop is equal to this. However, at the center of the loop, z is going to be equal to 0, so we can simplify that equation to this. So for two loops, we took this equation b that we solved for. We're going to set that equal to 2 times this equation right here and solve for I. And by doing some simple algebraic manipulation, we get what the current is.